Hello guys, welcome back to our channel. So today we are starting with another series of MHT-CET Formula Marathon, that is of Physics 11. All chapters we will be covering in this series. Till now we have completed of 11th, 12th Max and Physics of 11th as well. So today we will be starting with the Rotational Dynamics. So for all this I need your support. So please subscribe our channel, hit the bell icon and do comment. Let's begin with rotational dynamics. What is angular displacement? Angular displacement will be theta is equals to omega t, or it is arc length. Theta is equals to arc length divided by radius. This will be the formula. Angular velocity omega is equals to d theta by dt. This is the formula. Angular acceleration alpha is equals to d omega by dt. Linear velocity, which is denoted by v, is equivalent to ds divided by dt. We will be seeing about linear acceleration. Linear acceleration A is equals to dv by dt. Relation between linear velocity v and angular velocity omega. We need to find the relation. So v is equals to omega into r. This is the relation, or it is v is equals to omega into r. This is also relation between linear acceleration A and angular acceleration alpha. So it is A is equals to alpha multiplied by r, or it is A is equals to alpha into r. Here we have omega is equals to 2 pi, and this is also formula one of the, and this is, it can be also 2 pi by t, time period, where n is a frequency and t is a time period over here. Let me write over here, this is period, and this will be frequency. I hope you understand it. Now we have radial acceleration, so it is like radial acceleration minus omega square into r, or it is like omega square into r is equals to v square by r equals to v into omega. Now we have resultant force, which is minus m omega square r means like, or we can write m omega square r plus sum of the real forces which we have, real forces equivalent to 0. We have says now about centripetal force formula, mv square upon r equals to mr omega square, or it is mv omega. We have another formula of alpha. Alpha is equals to omega minus omega naught divided by t. This is also of the formula of alpha. Here it is angular acceleration. So alpha is angular acceleration. You can use this formula as well for it. Now we have maximum possible speed. So it is v max is equivalent to root of mu s into rg. Mu is coefficient of static friction and g is acceleration due to gravity. Minimum speed is v minimum root of rg divided by mu s, and normal reaction is n is equals to mr omega square mv square by r. Most safe speed vs is rg tan theta. This is the most safe speed. Now we have angle of banking. Theta is equals to tan inverse of v square by rg. V square by rg. Minimum possible speed vh is equals to rg tan theta minus mu s divided by 1 plus mu s into tan theta. Maximum possible speed, so it is v max equals to rg tan theta plus mu s 1 minus mu s into tan theta. This is of minimum, this is of maximum possible speed. Angular velocity omega. omega is equals to 2 pi by t. This I told you firstly. So we are going to substitute over here GE divided by L cos theta, all the formulas, and we will get time period formula, which is T is equals to 2 pi L cos theta divided by G. This is the formula. Now we have a frequency N. So L is equivalent to 1 upon T is equals to 1 upon 2 pi into G divided by L cos theta. For mass tied to a string, minimum velocity at highest point to complete vertical circular motion, VCM. So VH is equivalent to root of RG, minimum velocity at lowest point to complete VCM. So V at lowest, root of pi RG. Then we get to know about minimum velocity at lowest point to complete VCM. Now minimum velocity at midway point to complete VCM is V at velocity at midway, root of 3RG. Tension at any position. Tension at any position is M Vp square plus mg cos theta. This is the formula. Or you can write tension at any position is equal to 3mg 1 plus, where it will be 1 plus cos theta. Now we have tension at highest point in VCM, vertical circular motion. TH highest equals to M VH square divided by R minus mg. So this is a tension at highest point in VCM. Tension at midway. Tension at midway is equals to M Vm square divided by R. Tension at lowest point in VCM. TL is equals to M VL square divided by R plus mg. Difference between tension at lowermost and uppermost point. So lowermost minus T uppermost high is equals to 6 mg. This will be the difference over here. Now we get to know about more things, that is Vmax. Velocity at maximum is equivalent to root of Rg, upper limit on the speed. Ignore this, please. Moment of inertia, I is equals to integration dm r square. Rotational kinetic energy is equals to half of I omega square is equals to half of I 2 pi n the whole square. Translational kinetic energy, half of mv square. Now we have moment of inertia of a uniform ring. Moment of inertia of a uniform ring, I is equals to mr square. Surface density sigma is equals to m divided by pi r square, which is mass upon area. Moment of inertia of a uniform disk, I is equals to half of mr square, and radius of gyration k. K is equals to root of I divided by m. This theorem of parallel axis. I naught is equals to IC plus IH. I naught is moment of inertia of an object about any axis, and IC moment of inertia of an object passing through a center C. Mass of the body M is, and H is the distance between I naught and IC. Theorem of perpendicular axis, IZ is equals to IX plus IY. This is theorem. Angular momentum, L is equals to R cross P, which is L into R T into R sine theta, or it can be L is equals to I into omega. Tau is equals to I alpha, torque in terms of moment of inertia. Conservation of angular momentum. Tau is equals to dl by dt, and kinetic energy of a rolling motion. Kinetic energy of rolling motion. Let me change the color. Rolling motion equals to half of mv square plus I square, and it can be like equals to half of mv square 1 plus k square upon r square. This is also another formula which we can use. Velocity of a rolling body. V is equivalent to root of 2gh divided by 1 plus k square upon r square. Acceleration of a rolling body. Acceleration A is equals to g sine theta divided by 1 plus k square upon r square. Now, by this, we have completed this chapter of rotational dynamics. So, please subscribe our channel, hit the bell icon and do comment. Thank you for watching.